A very warm welcome to all of you, my dear subscribers, followers, ladies and gentlemen. I am starting a new series of simple data analysis for the beginners, and this series is started with the video number 391, in which I concentrate on the correlation coefficient, and I'll be sharing its theoretical underpinnings as well as how to compute correlation coefficient practically using some hypothetical data. And in this data, I'm going to answer some question. Can correlation coefficient be absolutely equal to 0, 1 and -1 or not? And if it is possible, in what circumstances it will be equal to +1 or -1? Before I do that, let me explain. In this video, I am focusing upon the Pearson product moment correlation rather than the Spearman's rank correlation. This one, that is the Pearson product moment correlation, is one of the most commonly used types of correlation measures which is used in practice, but there are some others. One closely related variant is the Spearman's correlation, which is similar in usage, but that is applicable only to the ranked data. A question is, what is correlation coefficient? It can be defined as the specific measure that quantifies the strength of the linear relationship between two variables x and y in a correlation analysis. The correlation coefficient is what we symbolize with a small letter r in a correlation report. The correlation coefficient r is a unit free value that ranges between -1 and +1, and its statistical significance is given by the p-value, or the significance value, or the probability value. Therefore, correlations are typically written with two key numbers, that is correlation coefficient r and the p-value small p. If r is closer to 0, then it means that the linear relationship between the two variables x and y is weaker. If the values of r are positives, then it indicates a positive correlation between x and y, where the values of both variables tend to increase in the same direction. Negative r values indicate a negative correlation, where the values of x variable tend to increase when the values of the y variable decrease. That is, when x and y vary in opposite direction. The values 1 and -1 both represent perfect correlations, positive and negative respectively. That is, when the r value is equal to 1, then there is perfect positive correlation between x and y. When r is equal to -1, then there is perfect negative correlation between x and y. Two perfectly correlated variables change together at a fixed rate. We say they have a linear relationship. When plotted on a scatter plot, all data points can be connected with a straight line. The p-value helps us determine whether or not we can meaningfully conclude that the population correlation coefficient is different from 0 based on what we observe from the sample data. As I mentioned earlier, we can also have situation when correlation coefficient could be positive, negative or 0. In this figure, we can see that the values of both x and y vary in the same direction, and the relationship between the two can be denoted by a positive line like this red arrow in this figure. If there is negative correlation between x and y, then the relationship between the two variables can be denoted by a negatively sloped line like that one shown as the red arrow sloping downwards. And if there is no correlation between x and y at all, then the straight line would be horizontal instead of positively sloped or negatively sloped line. So in that case, there is no correlation between x and y variables. How do we actually calculate the correlation coefficient? There is a statistical formula that will be shown to you in a while, and here it is. It is given by R, and R is the ratio of the covariance between x and y divided by the product of the standard variations of x and y variables. So R in this formula means correlation coefficient, and that ranges between -1 and +1. Xi denote values of the x variable in a sample. X bar shows mean of the values of the x variable. Yi shows values of the y variable in a sample, whereas y bar stands for mean of the values of the y variable. So as I mentioned earlier, the correlation coefficient is a ratio of the covariance between x and y divided by the product of the standard deviations of x and y. We can show when correlation coefficient R could be exactly equal to 1, less than 1, equal to -1, and less than absolute -1, and 0. So for that purpose, I will use some data, hypothetical data in SPSS. So I am going to open that data, and here is the data. So in this file, I have a number of variables x and y. So let me make it visible to you. Like this. So I have two variables x and y, and now let me go to analyze and a bivariate correlation. So one of my variable is x and one of my variable is y, and I have checked Pearson, and now I will click on OK. So it will calculate the correlation coefficient between x and y. So here is the result. The correlation coefficient between y and y is equal to 1. The correlation between x and y is also equal to 1, and the p-value of the this correlation coefficient is 0.00. In SPSS, when there are 3 0 to the right of the decimal line, it means that this is highly significant, and below it shows that the level of the correlation is significant at 1% level. So this is highly significant. But you see that the present correlation between x and y is exactly equal to 1, that is positive. So it shows that there is perfect positive correlation between x and y, and that can be seen. How this is so? So this is so because if you look at the values of x and y, they are exactly equal to each other. So when the values of the two variables for the various observations are exactly the same, then the correlation coefficient between those two variables will be exactly equal to 1. Now a question is, in what circumstances this correlation coefficient be equal to negative? Let me also show you this. By analyzing this, I will go to correlation coefficient, and I'll take this variable out, and I'll scoot this here, and in this case you will see the correlation coefficient will be exactly equal to -1, and it is here. Sorry, I made a mistake. So yes, this is exactly equal to -1. So there is perfect negative correlation between y and x. And how is it possible? Let me show you the data. You can see in the data these values are exactly the same as y values, but the only difference is that these values are negative, 100 and -100, 80 and -80, 70 and -70, 40 and -40. So if values of the two variables are the same, but values of one variable are negative and value of the other variables are positive, then in that case the correlation coefficient will be equal to -1. That is, there will be perfect negative correlation between the two variables. If we change only one variable, only one value of these two variables y, now x and y are exactly the same, but in this series I change only this value from 100 to this value, rest of the values are the same as y values. Then let us see what happens in this situation. If we see x1 diff mean I have made only one change to the value from 100 to 90, rest of the values of the x are the same. In this case, the coefficient of correlation is 0.990 but not exactly to 1. So it means if there is at least one value different than the other series or the other variable, then the value of the correlation coefficient will not be equal to 1. So by changing only one variable, the correlation coefficient decrease from perfect positive correlation to 0.99, although significance level is still 0.01. So there is high correlation between x and x1 diff. There is a third situation in which the correlation coefficient between y and x would be 0. In real world, if we have two series, it is not possible for both of them to have 0 correlation. There must be some statistical relationship, either positive or negative. Either the relation will be negative or positive, and may be significant or insignificant, but it cannot be 0. I'll search for that and will share with you another video if it is possible that we could have 0 correlation between two series x and y. So I hope, ladies and gentlemen, this is very interesting. We saw the definition of correlation coefficient, its various degrees, positive, negative, in its formula, and its practical example when correlation coefficient is equal to 1, when it is equal to -1, when it is equal to 0 point something but greater than 0, and less than 0 but less than absolute -1. This is very interesting, and this video is meant for the beginners, those of you who don't know about the basics of correlation coefficient. I hope by watching this video you can understand in what circumstances the correlation coefficient could be positive, could be negative, and how they look like, how the relationship may look like in a graphical exposition, and how can we compute the positive or the negative correlation, or when it will be equal to perfect positive correlation and perfect negative correlation. I hope you will enjoy this video. If you haven't yet subscribed to the channel, kindly subscribe to the channel, and do not forget to click on the bell icon so that you can get other videos about data analysis for the beginners or the starters. I thank you very much for watching this video. Kindly share this channel with your friends, with your colleagues, with your students, so that the benefit could reach to the maximum possible number. Thank you.